Welcome friends to our NPTEL MOOC module on health economics. We are discussing today on time inconsistency and health, in particular called discounting. Okay, so, what we did in the last class is on prospect theory developed by Kahneman and Tversky in comparison with the traditional expected utility theory. In this lecture, we will be discussing on beta delta discounting model, which is discounted due to time consistency or inconsistencies. Again, so far as time inconsistencies are concerned, it depends on the approach the person follows, whether he has sophisticated approach or the naive approach. We will discuss that. And the sophisticated one, again we will emphasize on what kind of commitment mechanisms are explained. More importantly, in this lecture, we are clarifying the possible biases due to the role of time. Okay, so time discounting, the simple meaning of it is that it gives to the individual about the highest value what the person is carrying at that time, and usually a person has a little less importance to the other time period or the different time period, and they are considered to be discounted. And if the same value persists in the mind of the people in different time period, usually we consider them as time consistency. Okay, so beta and delta method or the or the coefficient or the approach somewhere useful to understand the discounting aspects. We will also discuss about some possibility of hot brain versus cold brain model, and we also emphasize behavioral welfare economics context. Coming to the time inconsistencies, it is a soft theory within behavioral economics, and this gives a present bias. The person has highest biasness towards the present than the future. The time inconsistent decision makers are commonly described as having different selves at certain points in time that make inconsistent choices with each other. Like prospect theory, the notion of time inconsistency is a major challenge to classical welfare economics, which assumes that people have consistent, complete and transitive preferences. Some example of the time inconsistencies are procrastination, unhealthy lifestyle choices, impulse buying, smoking and substance abuse, credit card and led debt, and saving and retirement planning, etc., which used to have some importance to the role of time, and that too the T1 or the present period T0. Okay. So, like credit card users used to have the habit to spend higher amount irrespective of what kind of burden it is going to create in later periods. Similarly, smoking and substance abuse is also relevant to explain. Once you are getting used to it, you find it is more valuable than that of actually thinking about the future values. Similarly, impulse buying, unhealthy lifestyle choices, etc. So it has time inconsistency has strong relationship with health. Time inconsistency can explain many puzzles in health. Why people buy gym memberships but fail to visit the gym, why people postpone plans to quit smoking even when they know that it is creating adverse health. Why people have so much trouble seeking to a healthy diet. These are common examples where time inconsistency really plays an important role. Time inconsistency explains many other phenomena that the standard neoclassical economics cannot explain. Theory of time inconsistency also implies tools that both government and markets can use to improve ability to time inconsistent individuals to keep their cold brains plan. We are now heading for explaining the method for understanding the time discounting through beta delta discounting model. So, did you buy a ticket? One example we are just citing for you to start the understanding of this time discounting. Did you buy a ticket for the Cricket World Cup several months ago, or did you secure a ticket for Sonu Nigam's concert well in advance? Usually, this happens. People give value by purchasing the ticket in advance. Okay. And the fact that people make these purchases beforehand suggests that they derive utility in advance, explaining their decision to buy the tickets ahead of time. Individuals derive utility from both present joys and the anticipation of the future happiness. To accommodate this reality, economists represent total utility by combining the weighted sum of immediate utility levels in the current period with those from other subsequent periods. Hence, the total utility uh, which we are going to just discuss and is not just the present period, that the overall is actually is a function of all utilities in different time period. Okay. So, different time periods and the utility is important. So, we are supposed to actually add today, then tomorrow, then day after tomorrow, and so on. Here in this equation A, B and C, these equation, the coefficients are indeed the weights given to utility from different time periods. People do not value utility in all periods equally. So, these A, B, C etc. are not necessarily going to be equal. If it is following a constancy, then obviously it is not the time inconsistency model. Okay. Hence, the vector of weights which we just discussed, there A, B, C, T, etc., is called a discounting function, because we see that A is higher than that of other, then B is greater than that of C and so on. This is what we are actually writing here. So, discounting function a vector of weight that indicates how much an individual values utility in the present and the future periods. The beta delta discounting formulation is actually developed by Phelps and Pollock in 1968. So, as we just observed from the equation, the overall utility, we find that A is indeed greater than that of B than that of C. So, the beta delta discounting functions are assumed to be monotonically decreasing and reasonably approximated with two parameters. Okay. So, the two parameters are actually largely approximated. So, U overall or the utility overall is actually in the present period, that is delta to the power 0 plus in the second period beta times delta 1. Okay. Then in the third one it is beta delta square on the very next end and so on. So, that means overally we find that the beta, that is we just got it, will be equal to utility we get it at today, and where the delta value is considered to be following complete 1 at that moment. So hence utility of today that matters, it is delta to the power 0 and or on the present period considered to be 1. Rest are with a beta function of tomorrow and the next day etc., where delta to the power 1, delta to the 2 and so on. One thing is very important to mention that the beta has a strict upper limit and lower limit. It has 0 and 1, whereas the delta, the upper limit is of course 1, whereas the lower limit is not strictly 0, hence the bracket is different. So, beta is the present bias parameter, so which you have just shown you, is the present bias parameter that discounts utility in all non-current periods. So, since we have a strong bias, actually the bias gets discounted in other non-current period, whereas delta is the discount factor parameter that discounts utility incrementally more in each subsequent period. If beta declines below 1, means it has a presence of present bias and time inconsistency. If it is strong strictly 1, that means it is time consistent preference function or preference function. Okay. Within beta delta discounting model, if beta is strictly 1 or no present bias is identified, hence we are following a time consistent preference. Whereas the utility from period t is worth delta to the power t as much as utility in the current period. So, the exponential discounting function, which is just mentioned as delta to the power t, is explaining the extent of inconsistencies and the discounting. So, the utility overall is equal to u0 plus u0, because we have just said that there is no discounting, just 100% biasness is noted in the very first period, whereas in other period you just see that there are discounting and explained by the sigmas, the deltas. A discounting function with higher delta weights future utility more with higher delta weighs future utility more highly. So, higher deltas correspond to more patience and more forward looking behavior. Okay, so time consistent preference clarifies that the preferences shared across all cells, so that future cells will not alter a plan and that a previous self found optimal. So, coming to one example is mentioned originally by Becker and Murphy. They show that addiction is not irrational and addicts have time consistent preferences. Hence, they are in a position not to forgive their behavior because they have a consistent preference function. Hence, that they are not irrational. In 1988, Gary Becker and Kevin Murphy developed a theory of rational addiction. According to them, addicts are fully aware of their addictive nature, and this addiction does not create time inconsistency. You just take a note that this does not create time inconsistency. A fully rational time consistent nicotine addict picks the level of smoking in each period to maximize overall utility. Addict is indeed fully aware of increase in cigarette consumption in future and health issues caused. Thus, balances his cost against the upfront utility he enjoys from a cigarette now. Now, coming to another aspect called myopia and hot brains. as part of time inconsistent preferences. Here the preferences such that future cells will sometimes alter a plan that a previous cell found optimal. These preferences are also called myopic. Okay. So, usually myopic is considered to be short sighted, okay, because the future cell will surely alter that plan to as against the previous one. Within beta delta model, utility function is time inconsistent if and only if beta is less than 1. Okay. Okay, the resulting utility function is said to exhibit hyperbolic discounting, because in other one it is not going to be consistent or constant. So, these hyperbolic discounting might be of two types: steep discounting, very huge fall, diminishing rate of the utility in the future, or just a flatter discounting utility rate. We are just citing an example here, that how we will also calculate with the help of another real example. We are just giving you the background how you can proceed. Let an IT worker named Jaideep has utility function defined at any time t. Hence, we have just mentioned that t plus 1 and its delta function, then beta labels accordingly. For simplicity, take the time as month of January, February and March and so on. Given Jaideep's discounting factor, that is delta, Jaideep is planning his work schedule and leisure activities in the month of February. This will of course, then if it is so, then we can write down the utility function accordingly. Hence, the utility function of the January would be the present one with no discounting component. Then there will be beta of delta of utility February and delta square of utility March. And if the person, that is Jaideep, starts with the plan from February, then of course January is not that important in that case. They start with the discounting factor from March onwards. Okay, you can see delta to the power 1, then 2 from March onwards. If the plan is from March only, then of course the function will be accordingly varies. So, we are just presenting Jaideep's inconsistency and present bias. Where is the present bias based on the plan? So, initial planning, if in January Jaideep has a discounting factor of delta, which reflects his tendency to value future months less than the current month. In January, he plans his schedule with his discounting factor. His expected utility, which I have just mentioned, is like this. If a particular action such as quitting her job, or Jaideep case quitting his job and celebrating throughout February would bring his some employment in February, but result in significant discomfort of course in March, and his so January self would make a plan to avoid participating in such festivities. It depends upon where the plan and the starts. It starts from February, then March onwards the discounting matters. If it is in instead of January, if it starts at February, of course the utility function as per the time discounting would start from February, then the discounting factor starts from March. The shift in discounting means that Jaideep might now perceive the utility of February as comparison to utility of March as more valuable than he initially thought in January, because he is planning in February now. He quits his job and celebrate all month in February. So we can study the time inconsistent preferences by comparing how Jaideep feels about the utility in February or utility in March, in January. Okay, the different utility bundles of different months in January, and how he feels about the same in February because of his shift in his plan. So, as I already mentioned that in January he anticipates the discounting of, that is delta, between February and March if 3 months planning is there. As soon as he reaches in February, he realizes that the discounting between February and March is actually beta times delta, and his preferences becomes inconsistent with axioms of rationality. Now we are presenting another example with the similar approach by giving you a case with a numeric example. We start with Shruti's case. Shruti has 1001 pieces of candy which he has to eat in 3 months time period. Okay, maybe in January, February and March only, not extending beyond that period. Her utility function from this candy consumption is a logarithmic function, that is ux is equal to ln x. This is what we have just given as per the question, where x is the number of pieces consumed in 1 month, and let the utility function as given in the question is u1 x1 in the period of January and u2 x2 in February and March respectively, and u2 x2 in February and u3 x3 in March respectively. So, also Shruti has a beta delta discounter. So, this is what the hint is given to us. Now, what I will do, you may try in your home this question. We are giving you the hint in between. So, basically this is in short called Shruti's candy dilemma. What kind of utility based on the time discounting Shruti is deriving in different time period, what Shruti should do. So, write down her overall utility function in each month. Since utility function is already given to us, we can actually write it down. Okay. So, suppose we are supposed to go for writing overall utility function in each month, but the utility function is already given to us. So, it is logarithm function. So, we are supposed to write down through the beta delta discounting formula. So, we are supposed to have the utility function like this. In January, we have to note that in January what is there, and in January particularly, the utility function for the January in particular will be ln x1 plus then we are supposed to include the beta delta function, delta times ln x2, then of course beta delta square ln x3. Okay, since 3 period time is given to Shruti. Whereas if the plan is for the February, we have already mentioned that write down the overall utility function in each month. So, on the February month, what really happens? So, utility 2 let it be, then that will be, of course, then January is missing from the equation. It will be, of course, and there will be no discounting in the period of February if the plan is for the February itself. So, it will be L1 ln x2 and nn plus beta ln x3, or then discounting should be also given, beta delta then x3. Okay. So, it is not beta delta square, it is only first period, then March becomes first period at this moment. Okay. So, this is what we have just written. Now, coming to the second question. For the March, of course, as it is just ln x3. So, we are not writing down for the March. Okay. So, coming to from the perspective of Shruti's January itself, what is her marginal utility of adding a piece of candy in January? Okay. So, what is our marginal utility of adding a piece of candy in January? If a piece of candy is added to Shruti's consumption basket, as per the January sale plan is concerned, what sort of utility, marginal utility Shruti derives? Also find marginal utility from candy consumption in February as well as March for January sale of Shruti. So, what we do for the question number 2, we will discuss about marginal utility of adding. So, a simple term we have simply said du1 by dx1, and similarly for du 1 by dx2, then du1 by dx3, because we have already mentioned the question that the question is here, what is the marginal utility derived from the candy consumption in different periods if we follow the January plan or January sale of Shruti. So, try to understand that our plan is from January itself, hence the marginal utility of editing the or adding the utility to the next month starts from the changes in the January itself. Hence, the utility plan, the total utility, overall utility is this one which you have just derived. Now, from there we will take du1 by dx1, then of course, from this equation it will be 1 of x1 time 1 of x1, because it is then dx1 by dx1. So, it is cancels out and it is only 1 upon x1. So far as du1 upon dx2 is concerned, then from the second component others are going to be 0, and here our common component will be beta beta delta. Okay, so that is actually beta delta, then upon, of course it will be 1 upon x2, okay, or divided by x2. Then the third component, it will be du1 by dx3, it will be equal to beta delta square divided by x3. Okay. So, we have just mentioned this here. So, now we are going to discuss about the third question. First we have done it, second we have also done it, then we are going to address the third. Suppose Shruti is time consistent, that means the beta is going to be 1 and has a discount rate of 0.5, okay, and discount rate is now no more same. So, it is actually 0.5. We have already mentioned, if we discount every time discount rate is half, then allocate all the candies in 3 months, maximizing overall utility. So, that means every month the target is to actually maximize the each month's overall utility. Hence, the change in utility in each month due to the allocation of the candy, okay, should be equal to each other. That means du1 x1 is equal to du1 x2 is equal to du1 u1 dx3, etc. So, in this case a hint is also given that each piece of candy will give equal satisfaction to her, and therefore, to maximize her overall utility she chooses a candy allocation that equates her 3 derivatives from the previous exercise. So, that means we are supposed to equate. So, our question try to understand, we have given a value that if beta is consistent and we have a time discounting rate that is 0.5, then you allocate the candy so that the utility gets maximized. So, what is that allocation of the candy? That is our question. So, first aspect in the question 3 is that we have to discuss about one equality condition at this moment, that your first order derivative based on the January plan all are maximizing, that is the hint has already been given. So, that means you have du1 by dx1 should equal to du1 divided by dx2 should equal to du1 divided by dx3. So, this implies you should have 1 x1 1 upon x1 should be equal to beta delta to the by x2 should be equal to beta delta divided by x3. Okay, that should be following. Now, if we just simply put the value which is given to us, what the value it is given, you just check on your own what the values are actually given. Beta is following a time consistent pattern, and we have a discounting rate, that is the delta equal to 0.5. So, in each case we can put our values. So, this implies that 1 upon x1 should equal to your beta is 1 and delta is 0.5. So, 0.5 divided by x2 should equal to now, so 0. Now a square of 0.5, so it equal to 0.25 divided by x3. Okay. Now, this is what very clearly mentioned. So, if we just simply solve this, you will find one thing very clearly, that here this is 1/4. Okay. So, what is important here, we have already mentioned that the x1. So, from this what we derive is that x1 equal to 2 x2 is equal to 4 of x3, isn't it? So, this is what is actually derived. Now, if you put this together, and we all know that the total candy pieces, total number of candies Shruti has actually 1001. Okay. So, for all these periods it has to be consumed. So, that means x1, x2 and x3 should be actually utilizing or consuming the entire 1001 candies. But we have already got an identity that this is equal to this. So, if you simply put it to find out the value, we can just simply put in the place of x1 equal to 4 x3, then then x2 x3 etc. X1 equal to 2, and if you just simply put this, you will find a value like 4 x3 plus 2 x3 plus x3. Okay, this is what we just said, because x2 is equal to 2 x3. From this we can easily find out that x2 is equal to 2 x3. So, we have just put it here, then x1 equal to 4 x3, then x3 is there. So, this should equal to 1001. If you solve it, this is actually 7 x3 is equal to 1001, and hence x3 value we have already derived, that is 1001 divided by 7. Okay. So, this is roughly equal to 143. So, based on this identity we derived, we can derive other figures. So, x3 we have derived, then similarly we can also derive the value of x1. So, x1 is equal to 4 times x3. So, 143 into 4. So, it is equal to 572, and then x2 is equal to 2. So, x2 is actually 2 x3, then double of this, that is 286. Now, what is very important in this case, comparing x1, then x2 and x3. As per our question, you can just read what kind of allocation Shruti is going to make it given the discounting rate of 0.5. It is quite obvious that given the 0.5 of discounting rate, Shruti is allocating 570 in the first period, then the second period less of it 286, then the third period it is 143. I hope it is quite clear, and you can also try on your own. On the next question, you just see, will Shruti reallocate her distribution in February? If it is the, we started with January actually, January plan of Shruti, but if the reallocation is mad, like each Shruti going to reallocate her distribution if the plan is through February. So, that is, then the utility function has to be again reframed. Okay, the utility based on the logarithm function which just did it, we can do it here as well. Hence, the utility function will start from x2 onwards, x2 and x3. Okay. So, for question number 4, we just have a look what we did, that for Shruti's February self, we know that in the first period it is of 500 and 72 candies have already been distributed in January itself. So, how much out of the 1001 candies are left, that is 1000 minus 572. So, for the other 2 period, that is for x2 and x3 period, the total candies has to be actually 1001 minus 572. So, that should be 429. So, these candies are left for other 2 period, that is February and March, that is for x2 and x3. Okay. Now, we have a utility function given. So, the utility function we have to reframe. We know that utility is equal to logarithm function ln of x. So, the utility at period 2 will be, of course, there should not be any discounting in period 2 because we start from the February plan. However, there will be a discounting by the figure delta of x3. Okay. Again, we are supposed to take the marginal changes or the marginal utilities by taking the first order derivative of this u2, which you already did it. Now, it has to be with respect to x2 first. So, it has to be then 1 upon x2. Then for the second one, that is du2 divided by dx3, it has to be beta delta divided by x3. Okay. That is, now we have got it. Now, as per our first suggestion given, that the consumer is actually attempting for optimizing the utility, hence the marginal changes has to be actually equal, okay, in the utility bundle. That this implies that as per the question, 1 upon x2 should be equal to beta delta of an x3. That means this means 1 upon x2 is equal to delta is 0.5, we have already taken. Now, that is, and beta is 1, so it is 0.5 divided by x3. Okay. So, you can easily find out. So, x2 is equal to 2 times x3. Okay. This is what we have derived. All right. So, we did it. Now, similarly, so based on the value, we know that this total x2 and 2 or x this is, that is in total we have how many, 3x3, isn't it? So, how many are left? It is actually 400. So, in total we have x2 plus x3 is equal to 429. This is what we did it. We already mentioned it. So, now x2 is equal to 2x3. We just derive this. So, 2x3 plus x3 is equal to 429. This implies x3 is equal to 429 divided by 3. So, this is precisely 143, and based on this we can also find out that x2 is equal to 286. So, this one. Now, we just go back and check what we derived in the previous case, where the plan was from the January for Shruti to start her plan from January, and they are discounting based on the discounting rate of 0.5. The allocation was indeed for the x2 it was of 286 and for x3 it was 143. Now, precisely the same is actually derived again if the plan is from February. So, this means that since the discounting rate is constant, that is 0.5, we are actually getting the same rate even if it is planned from February. So, that means same reallocation as in January Shruti did. Now, the last question, that is question number 5, if Shruti is a hyperbolic discounter, all right. So, this means it is attached with the beta values as well as the discounting factor or the value. So, delta, so 0.5 times another zero point 0.5. So, beta times delta both matters. How we will see allocate candies again in January and February? We have already derived the utility function for January, February. We are supposed to simply, for the question number 5, we have already got the function, that is for January plan. Again we have to do the same approach we did it January and February. We derived it by x1 is equal to beta delta divided by x2 equal to beta delta square divided by x3. This is the identity we derived from the function. Now we are just simply going to put the values of beta and delta. So, if you put the beta and delta here, 1 by x1 would of course 0.5 into 0.5 equal to 0.25 divided by x2 should equal to then 0.5 square. So, it is precisely 125 divided by your x3. Then by solving this, we will find the value of x1 equal to 728, then x2 is equal to 182, and then x3 equal to 91. Now, you just see the changes as compared to when there is no hyperbolic discounting. Okay, and now in this case, one interesting find you will get it for the February from the equation. From the February one, the marginal utilities are this one equal to 0.25 divided by x3. From this you will find x2 equal to 218 and x3 is equal to 54.6. Now, you just compare x2 of February plan and x2 of January plan. Okay. Then x3 of February plan is against x3 of January plan. So, you will find there are changes because of hyperbolic discounting. Okay. So, it is not same, earlier we saw that it was same, but now you will find differences and it has again reduced. Rather, Shruti will feel that it is better to consume or get more utility from the first period itself, that is in January, because more consumption attempts are taken in January itself, because discounting rates are very high in the later period. So, that's for that's so far as candy dilemma is concerned. We have clarified based on the example. So, now you can there are some couple of other context I am just wrapping through. I am not explaining much since we have already consumed time. I am just going to tell you what are there in our basket for this explanation. I may give you time. Okay, let me explain this in another 5 minutes, and with that our approach will be completed. Our target will be completed for this lecture. So far as hot brains and cold brains models are concerned, I think I will suggest you to read. You might have seen thanda dimag, garam dimag, where hot brains where short sighted actions are usually noted, decisions are noted, and this is strong time inconsistent preferences. Okay, whereas cold one, they actually plan for the everyone, and they have a strong position for the consistency in their approach or the preferences. So, I am not discussing much here. I am just linking with one discourse called neuroeconomics, which were mostly discussed. Another one is called commitment mechanisms. Once commitment is made, then people usually stick to their approach, and they usually make them as a more consistent once commitment is made. So, like restricted savings account that prohibit withdrawals until the holiday shopping season, like alarm clocks that shred 100 bills each time the snooze button is pressed. There are some examples given, like alarm clocks example. Let me clarify that if any if you are not consistent enough in your regular schedule and you have taken the help of a alarm clock, your alarm clock is actually chargeable. If you are putting your hand on your snooze button, then you are supposed to pay a certain amount. Hence, the alarm clock is actually indicating that you are not consistent in your behavior. Once you are consistent, you might have woken up earlier, no need to put this snooze button. Similarly, other example we have given, I can go through for further clarity. Coming to another clarifications and some conceptualization are required, called sophisticates versus naive. So, sophisticates are the one who aware of their own time inconsistency are called sophisticates, but whereas naive are the people who are unaware of their own time inconsistency, and a naive will not demand any self commitment device, whereas the sophisticate will demand a self commitment device because he or she has knowledge on it. So, you can please read in between, I am not mentioning much. Coming to the same smoking addiction model, which I already started discussing under different discounting scenario, you will have certain aspect called experimental discounting, naive discounting, and sophisticated hyperbole discounting, etc. I am not discussing much on it. I am sure by reading this, if you have any difficulties, I will be happy to address it later. And hence, behavioral, another last part of our module of this lecture is on behavioral welfare economics. How best to judge whether an intervention benefits or harms a person with time inconsistent preferences. Some of the assumptions of traditional welfare economics no longer apply, as interventions might benefit some cells within a person while harming others. Some of the other important part of the discussion of behavioral economics are called rebuild preference approach, and sometimes we count for the long run preferences, and other guidance we have clearly mentioned. I think need not be read between the line at this moment. I hope you will follow, and rest I will take it off at the time of discussion. So, all we are just presenting here, which utility functions should be maximized in the case of time inconsistent preferences. We have given a rebuild preference approach, maximize long run utility one, dictatorship of the present, hot brains in invalidity, etc. You please follow the Jay Bhattacharya at chapter number 24. Rest of the discussion we have made it. I think it's not right to discuss everything. It's up to you how you are going through. So, last component is part of the welfare economics, but little departure from that is Pareto self improving commitment mechanisms. But Bhattacharya and Lakdawala 2004 propose a more caution approach to government intervention in the case of time inconsistent preferences. In this, commitment mechanism presents self drives for future selves, like for the future when discountings are atas, sometimes the bribes to reserve and make it consistent for the future actions are usually made, and hence commitment devices are called Pareto self improving. So, rest I am not discussing much. I am sure you must have got so many directions for your thinking, and we have cited the respective book and will be highly useful for your understanding. So, in the next unit number 7, we will start the economics of health systems. That is all. Thank you.